Today what we will do is, we will look at Le Chatelier's principle, we'll do a small experiment, and then we will discuss the changes in equilibrium and how it affects the equilibrium accordingly, all right? So let's look at our experiment first. One sec. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will demonstrate Le Chatelier's principle in the lab, where we will take cobalt chloride in solution and change the concentration of the forward and the reverse reaction to see what happens. Now to begin with, if we take the COH2O6 2+ ions, and we see that when we have the solution in front of us, we see that the solution is red. Now, when we add hydrochloric acid, and we know that hydrochloric acid is made of H+ and Cl- ions when it is in solution. So when we add HCl, actually what we are doing, we are adding Cl- ions in solution. And we know, according to Le Chatelier's principle, that if we increase the concentration of a substance, like in this case Cl- ions, then the equilibrium must do the opposite and try to reduce the stress. So in this case, because we've got too much of Cl- ions, the system must reduce the amount of Cl ions in solution, and to do that, the equilibrium must shift to the other side. It means that it favors the reverse reaction. So the Cl- ions are used up, where it reacts with the COH2O6 2+ ions, and COCl4 2- ions are formed, and H2O is also formed. Now let's look at the demonstration as it would be in the lab. So here we see that HCl is being added to the COH2O6 2+ solution, and we add the Cl- ions to it, and we see that the result is the blue color immediately when the HCl comes into contact with the COH2O6 2+ solution. Now coming back to our equation that we have here, we see that if we have now, if our solution is blue and we have a high concentration of COCl4 2- ions, and we add water to it, then what will happen is, according to Le Chatelier's principle, the stress is an increase in the H2O. So the system must reduce the H2O in the solution, and in order to do that, the H2O will react with the COCl4 ions to favor the forward reaction, and as a result, COH2O 6 2+ ions are formed, and 4 Cl- are formed. And the result for us is that when water is added to a blue COCl4 2- ion solution, the blue solution will turn red, which shows that the forward reaction is favored. So here we see a simple demonstration showing us the Chatelier's principle, and it demonstrates the change in concentration clearly, where an increase in concentration causes the reaction to shift onto the other side. So if we increase, for example, in this case, if we increase the concentration of H2O, then the reaction turns red, which shows that the forward reaction is favored. And if we increase the concentration of the Cl- ions, we see that the reaction turns blue, which shows that the reverse reaction is favored. Thank you very much for watching. Okay, so now we've looked at the Chatelier's principle in action. You saw an explanation
about the Chatelier's principle, right? And we saw what will happen if there's a change in concentration of a reversible reaction. So if a system at equilibrium experiences a change, whether it's concentration, temperature, or pressure, the equilibrium will shift in order to minimize the change, and a new equilibrium is established, as you saw in that demonstration where we changed the concentration. Now, when we do it in terms of our exams or when we're writing it in a test paper, you have to, if it's a, they say if the question says use Le Chatelier's principle to explain, then it's about 3 or 4 marks. Then you should do it like this. First, you should identify the stress. What is the stress? What is the disturbance? Like in the one we did, the Cl minus ions was increased. Then, according to Le Chatelier's principle, the system will cancel the effects of the stress. As a result, you can say the forward or reverse reaction is favored, and then we can say because the forward or reverse reaction is favored, the result is the concentration of this increases or the reaction of that decreases, and as a result, the color changes as such. So let's look at let's look at an example. Before we look at an example, you all did this yesterday. This was the summary of the effects of the Le Chatelier's principle. Sometimes they ask you a question just for 2 marks, then they just want the effect. What is the result? Then you write it like this. But if they say use the Chatelier's principle and they give you a 4-mark question, then you must explain it in terms of a long story, right? So let's look at the effect of a change in concentration on a chemical equation. So first, I've wrote down the 4 main points: stress or disturbance, according to Le Chatelier's principle, for reverse result. And let's take an example, the same example that we did in terms of our demonstration, right? We know that the COCl4 2 minus ions are blue, and the COH2O6 2 plus ions are pink. All right. Now, let's cause a change to the system. If HCl is added, all right, so write this down. If HCl is added, now what is the disturbance that is caused? By you adding HCl, the disturbance is you've increased the concentration. We're talking about concentration here. We're changing the concentration of the Cl minus ions in solution. So that's the first point. You must write it down. When HCl is added, the disturbance is an increase in the concentration of the Cl minus ion solution. You can write concentration as well, right? Concentration of Cl minus ion solution. Right. Then we can say, according to Le Chatelier's principle, the system will favor the reaction that decreases the Cl minus ions in solution. Okay, we've got that down. Then you're writing down the answers, correct? And then the third part, which reaction is favored now? The reverse reaction is favored, isn't it? Because more, the solution must turn blue. All right. So the reverse reaction is favored. And what's the result? As a result, the pink COH2O 6 2 plus ions are used up, and COCl4 2 minus ions are formed. So that will be how you will answer this question using Le Chatelier's principle in detail. All right. So that will be the first answer that we have, the change. All right. The effect of a change in concentration on a chemical equilibrium. Okay, let's take another example. The effect of a change in concentration on a chemical equation. Now, in this case, we have the same equation, all right? And if water is added. So the effect of a change in concentration, if water is added. Now we must write it in 4 steps. So write it in 4 steps. Yeah, right. Yeah, all right, all right. Yep. Okay, if water is added to the system, the disturbance is first an increase in the concentration of water. Then, according to Le Chatelier's principle, the system will favor the reaction that decreases the water. Right, that's the opposite. And when we look at it, we see that the forward reaction is favored, and the result will be the blue color. The blue cobalt chloride ions are used up, and the pink COH2O 6 plus 2 plus ions are formed. So that will be the result, the change in concentration. The concentration change, right? Now let's look at another example. Say we take that same equation, the effect of increasing the temperature, a change in temperature on an equilibrium situation. So say they give you the same equation, cobalt COCl4 2 minus plus 6H2O giving you COH2O 6 2 plus 4 plus 4Cl minus, but they tell you that delta H is less than 0. So if they tell you that delta H is less than 0, what does that mean? If delta H is less than 0, that means that the forward reaction is exothermic. So if the forward reaction is exothermic, then the reverse reaction will be endothermic. So let's see what is the disturbance that we're going to create in this case. So if temperature of the solution is increased, if the temperature of the solution is increased, right? So write down, the disturbance will be, what will the disturbance be? The disturbance will be an increase in temperature. Then what do we know? If the disturbance is an increase in temperature, according to Le Chatelier's principle, the system will want to reduce the temperature to favor the reaction that reduces the temperature. All right. So which reaction will be favored? The forward or the reverse, the endothermic or the exothermic reaction? The system that will absorb that excess heat that's given off, right? So therefore the endothermic reaction is favored. The reverse reaction is endothermic. So the reverse reaction is favored. The pink COH2O6 2 plus ions are used up, and the blue COCl4 2 minus ions are formed. The solution will become blue because it favors the endothermic reaction, and the reverse reaction is our endothermic reaction. Okay, let's look at another example. If we take the same example, delta H is less than 0, that means the forward reaction is exothermic, right? And now what we're going to do, the temperature of the solution is decreased. So if the temperature of the solution is decreased, then it will favor what? Which reaction? Let's write down the solution in terms of 4 steps. The disturbance is a decrease in temperature. According to Le Chatelier, the system will favor the reaction that increases the temperature. Which system favors an increase in temperature? The exothermic reaction is favored, right? The exothermic reaction is favored. So which is the exothermic reaction? The forward reaction is favored. As a result, blue COCl4 2 minus ions are used up, and the pink COH2O6 2 plus ions are formed, and the solution will become pink. All right, so that's the way to explain the equilibrium shift using Le Chatelier's principle. Now let us do one more example. The effect of an increase in pressure on a chemical equilibrium. So here also what you should write down, make a note that an increase in pressure on a chemical equilibrium, before I do that, when we come to temperature, the effect of a decrease in temperature and an increase in temperature, all right? What you should know is that if there's a change in temperature, an increase in temperature favors both the forward and the reverse reaction, all right? And a decrease in temperature decreases the rate of both the forward and the reverse reaction, right? But if you increase the temperature, the rate of the endothermic reaction increases by a greater amount than the exothermic reaction. And if you decrease the temperature, the exothermic reaction is faster than the endothermic reaction. So we don't, you just have to know that, but we'll write it as it is here. If you decrease the temperature, the exothermic reaction is favored. All right. Now, if we take the last case, pressure, the effect of an increase in pressure on a chemical equilibrium, this only affects gases, right? So when we say NO2 and N2O4, we're talking about N2 and NO2 and N2O4 as gases in an equilibrium, all right? So now they've given you the equilibrium, they told you the color of NO2 is brown and the color of N2O4 is colorless. And they're asking you that if the pressure is decreased, how will this affect the rate of the reaction? So when we talk about pressure decrease, we must see the number of moles or molecules in a reaction vessel, closed reaction vessel, right? So the first step is to state the disturbance or the stress. The pressure is decreased, that's your disturbance, right? And according to Le Chatelier's principle, the system will favor the reaction that will increase the pressure. So how do you increase the pressure? By you having more particles that are knocking on the side of the container, there'll be more collisions, more pressure, right? The reverse reaction results in one molecule forming two molecules. That is the reverse reaction will be favored. The reaction that has more molecules is favored. Because if there's more molecules, there's more collisions with the side of the container, it will increase the pressure. And what's the final result? If more NO2 is going to form, what color change is going to take place? The colorless N2O4 molecules are used and brown NO2 molecules are formed. The reaction vessel will turn darker and will become brown, right? We're looking at the last one. If the pressure is increased, the pressure is increased, all right? So if the pressure is increased, what will happen? According to Le Chatelier's system, the favor will favor the reaction that will decrease the pressure. So how do you decrease the pressure? In terms of the number of molecules in the container. The forward reaction results in two molecules forming one molecule. Therefore, the forward reaction is favored. And as a result, brown NO2 molecules are used and colorless N2O4 molecules are formed. Okay, so this is basically an explanation using chemical reactions to show the reaction of this table that you did yesterday, to show that if the concentration is increased using Le Chatelier's principle, how it is formed, and if the pressure is decreased, how it is formed. So we look at this one. If the concentration is increased, what will happen? You must write it in 4 steps. If the concentration of the products and the reactants change, here's another example with water. We looked at the example of an increase in temperature. An increase in temperature favors the endothermic reaction. That is the highlight, right? And then we know that a decrease in temperature favors the exothermic reaction. And then we know that an increase in pressure, a decrease in pressure favors more moles, right? And a decrease in pressure, an increase in pressure favors If pressure is decreased, sorry, this must be decreased, no? An effect on a decrease in pressure. All right. If the pressure is decreased, then the reverse reaction results in one molecule favoring two molecules. So that is favored, you increase one with more moles, and increase in pressure, you favor one that makes less moles. So that will be an explanation of the Chatelier's principle according to the 4 steps that are important when you are explaining using a long explanation. That will stop today. Let's just check it again.